Yeah, but when you get 3 variables, you mess up it.
We're not, we'll do 3 variables tomorrow. Yeah, you're right. When you get 3, it's interesting. Okay, so in this section, we're going to look at, and this should be review from Algebra 1 and Algebra 2. So 7-1 will be a very pleasant one, except the word problems. We may not like those.
I don't like those.
In example 1, it says, consider the system x plus 2y equals 2, x minus 2y equals 6. Determine if each ordered pair is a solution. So in letter A, what you're going to do, you plug in the x and the y. This is 4 minus 2 is 2. It works in the first one. And you have to make sure, though, that it works in both of them. 4 plus 2. So this is a yes. You guys try letter B. It has to work in both. And if you plug it in the first one and it doesn't work, you don't need to bother putting it in the second one because it doesn't work. Yeah, Jay.
If you can do it in your head, you have to work it out.
You do not. If you can do it in your head, that is terrific. And I want to point out to you that I also gave you the homework. Do you remember that? Okay, so you're going to do for today, there were 12 problems for 7-1. And I intended for you to do them on your own paper, just so I could condense that down. All right, letter B, are you getting no?
Yes.
Okay, cool. All right, example 2. Use the substitution method. Substitution is when you either have one letter alone or it's kind of easy to get one letter alone. So if I look at the second row, if I add 2y to both sides, that would leave me with x equals 2y minus 3. And then you go substitute that. That's why it's called the substitution method. I'm going to go to the top row and replace x with 2y minus 3. The reason why we do that is, frankly, you can't solve a system with 2 letters. You actually can't. But if we rewrite it using substitution, now I can. I've only got one variable. So I'm trying to rewrite it in such a way that I can figure it out. So this is 10y minus 15 minus 4y equals 9. Let's multitask. 10y minus 4y is 6y. Add 15, so y is 4. Remember, linear equations, that's where you have 2 lines. The solutions are where they intersect, so it's a point. So then you've got to go back, take 2 times 4. So 8 minus 3 is 5. So my solution, I don't know why I'm making a 3. It's a 4. So the solution should be 5, 4. Yeah, Joey?
Does it matter, like, if you were, okay, so if this was question on the test, could you have just multiplied the bottom by -2 and then got rid of the 4? Got rid of the y.
That's called the elimination method. So, like, if it says use substitution, I'd like you to try substitution. Okay. So, I'm just trying to go through the method. Now, if the quiz just says solve it and you pick, you can do it any way you want.
Okay.
Okay? Well, in 8.1, I'm going to show you how to do matrices. Did you guys do matrices in Algebra 2?
Yeah.
That's where the little thing like this. There's a really cool way to do the 3x3s. Yes, I'm going to make you painfully do them by hand, algebraically, and on the quiz I say do it algebraically. And then I'm going to say, use your calculator now, and it's a keystroke. Okay, example 3 says solve the system using the elimination method. So then I'm going to do what Joey suggested. You can actually pick any letter, X or Y, to get rid of. Sometimes you multiply one row and sometimes you have to multiply both rows. In this case, if I multiply the top row by 4, this would give me 12x plus 8y equals, and what is that, 32, carry the 3. So then adding together, I get 21x equals 168. Okay, do you see that? I chose to get rid of y. You could have multiplied the top row by -3 and gotten rid of the x. It doesn't matter. Now I'm going to divide by 21, and I'm getting x is 8. Plug it back into either of the original equations. So let's say I do 3x plus 2y equals 48. And I'm going to plug in that x is 8. Well, 3 times 8 is 24. Subtract 24. You should get y is 12. So this is 8, 12. Now, with 7.1, I'm expecting that you know this, okay, that this is just a brief refresher. Yeah.
Okay, I pretty much understand it, but how did you get rid of the y again?
I multiplied the top row by a 4, and that gave me 12x plus 8y equals 192. Then I took this second equation and added it together.
Okay.
And negative 8y plus 8y canceled. It disappeared.
Okay. That makes sense. I was just confused.
Okay, so we have substitution, you have elimination. Then we're going to look at special cases. So in example 4, letter A, I don't know, let's choose to get rid of x. So if I multiply the top row by a 3 and the bottom row by -2, what that does for me, I get 12x plus 18y equals 36. The bottom row is negative 12x minus 18y equals negative 24. I chose to get rid of x, and you're looking for combinations of numbers that are going to make the coefficients of x to be the same thing, except one's a plus and one's a minus. I could have gotten rid of y, but now watch what happens when I add these. I'm getting 0 equals 12. This is false. The variables have dropped out, and I either get a true statement or a false statement. If it's false, it's no solution. If it's true, it's infinitely many. And let's make a connection graphically. If you have a system with 2 lines, the first 2 we did, example 2 and 3, they were 2 lines that intersected in a point. Graphically, what case is it that there's no solution?
Parallel.
They're parallel. And then the one that is infinitely many, it's one line that is itself, and so it's infinitely many times intersecting with itself. So guess what's going to happen in B? In letter B, do you see how this one lends itself to the substitution method? I did it on purpose. So I'm going to just substitute for y, that's 3x minus 2. So that's 15x minus 15x plus 10. I get 10 equals 10. It's infinitely many solutions. Unfortunately, I don't have a symbol for this. And don't think it's all real numbers, because it's actually not all real numbers. It's not anything I want. It's every distinct point on that one line. Okay? All right, any questions? All right, now we're going to get to the actual pre-calc part. So this part was just algebra 2. The next 4 examples, we're going to take it up a notch in terms of how do you get to a system. Example 5 says a chemist working on the flu vaccine needs to mix a 10% sodium iodine solution with a 60% sodium iodine solution to obtain 50 milliliters of a 30% sodium iodine solution. How many milliliters of the 10% solution and of the 60% solution should be mixed? So here's what I like to do. You're going to take a 10% with a 60%, and you want to make a 30% solution. So I don't know how many liters of each, except I do know there's 50 milliliters of the 30%. So X is the number of milliliters at 10%. Y is the number of milliliters at 60%. So then what you can do is you multiply these. And then what is 0.3 times 50? Wouldn't that be 15?
Yeah.
So this is sort of like this box that's going to create our system of equations. X plus Y is 50. The number of milliliters at 10% plus the number of milliliters at 60% has to equal the total number of milliliters. Then you take 0.1x plus 0.6y is going to equal 15. So it's actually not that bad. Yeah, Kenzie?
How do you know which one is which one?
It really doesn't matter. I mean, like, I could have said the 10% was y and the 60% is x. It doesn't matter. But be consistent, then if you stick with it, then in your next row, make sure that's going with the right thing. So now, what I like to do, because I've got the decimals here, I personally prefer with this type to do substitution. So you might say that y is 50 minus x, and then I get 0.1x plus 0.6 times 50 minus x equals 15. You don't have to solve it that way. You could move the decimals on the bottom row and then multiply by -1 or whatever you want. I don't know, to me it makes just a little bit more sense to do it like this. All right, so let me give you a head start on me and try and solve that. Now, in a word problem, it's going to be really, really important that you're identifying what you're finding. Don't just put 30 and 20. Like, now we're talking different things. So when I worked this out, I got x was 30. Well, that represents 30 milliliters at the 10% solution. Well, you know there's a total of 50 milliliters, so the other one has to be 20 milliliters at the 60%. All right, everybody got it? All right, let's flip and look at example 6. Okay, when a small airplane flies with the wind, it can travel 450 miles in 3 hours. When the same plane flies in the opposite direction against the wind, it takes 5 hours to fly the same distance. Find the average velocity of the plane in still air and the average velocity of the wind. So what I'm going to do is I'm going to let x be the velocity in still air, And I'll let y be the average velocity of the wind. We do know that distance is rate times time. Distance is rate times time. Well, rate is your speed. Velocity gives you direction and how fast you're going. Velocity is a vector. So there's a little connection. All right, so if I want to look at the trip with the wind, if I'm going to take the velocity times the time, it should give me the distance. And I don't know if you've ever flown in a plane, but sometimes, like, depending on what the direction of the wind, sometimes, like, you arrive 15, 20 minutes early, it's because you were going with the wind, and it pushed the plane faster. And then sometimes on the return trip, you're a little bit late, and it's because you're going against it. So you're going to take the velocity in still air, and then you're going to add, you have wind speed, really. The time it took going with the wind is 3. And so distance is that velocity times time. And then we have the trip against the wind. So you're going to have the velocity of the plane in still air, and you're going against the wind speed. On the way back, it took 5 hours. And you're going the same distance. It was 450 miles. So I like these boxes. The boxes help me. So watch how I'm going to come up with my system. Your distance, 3 times x plus y, the distance was 450 miles. So flying there and back is 450 miles. Now I want to show you a little trick, a little technique here. One thing you could do is you could multiply through by the 3, but guess what? Since it's an equation, I can actually divide both sides by 3 and get x plus y equals what, 150. And if I divide by 5, I get x minus y equals 90. And then guess what happens? If I use these two, can't I just add them together? Because the y's will cancel. Let me talk you through it one more time. I took each of these original equations and I could divide both sides by 3, and that left me with x plus y is 150. I can divide by 5 and get x minus y is 90. Now add them together. That gives me 2x equals what? 240. So x is 120. This is miles per hour, and that's the speed in still air. Then what would y be? You can use any of these 4 equations. Yeah, y is 30. And what does y represent? That's the wind speed, right?
Yes.
That's your wind speed. All right, so you've got some homework problems on this. All right, last type. This goes together. It's called break-even analysis in business. If you are majoring in business, business majors take business calculus, so you don't get away from this stuff. It says a company produces and sells X units of a product. Revenue is the price per unit sold times X, like the number of items you sold. So let's say, who makes the Xbox?
Microsoft.
Microsoft, okay. So an Xbox is what, about $400. at the store. If the store sold 10 Xboxes, you would take $400 times 10, which is 4,000. That's the revenue. That's what revenue means. The cost function is your fixed cost plus the cost per unit produced. So say Microsoft, they have to pay for their building and the employees, their salary. That's a fixed cost. But then to actually put the Xbox together, I don't know, say maybe it's $100 to make an Xbox. So you take 100x plus whatever their fixed costs are. Because like they have to pay for the telephones they have in the building, the electricity they use, you know, the water, the plumbing. Like there's a lot involved. It isn't just, oh, add up a little bit more so you make a little bit of money. It doesn't work like that. All right, the point of intersection of the graphs of the revenue and cost functions is called the break-even point. The x-coordinate reveals the number of units that a company must produce and sell so that money coming in, the revenue, is equal to the money going out, the cost. The y-coordinate of the break-even point gives the amount of money coming in and going out. So in example 7, it says technology is now promising to bring light, fast, and beautiful wheelchairs to millions of people with disabilities. A company is planning to manufacture these radically different wheelchairs. Fixed cost will be $500,000, and it will cost $400 to produce each wheelchair. Each wheelchair will be sold for $600. Letter A says write a cost function for producing X wheelchairs. So the cost function is the fixed amount, which is $500,000, plus it costs them $400 per wheelchair. So my cost function is 500,000 plus 400x. You cannot add them together because they're not like terms. The revenue function is you're going to bring in $600 per wheelchair. So the revenue is 600x. It says in letter C, determine the break-even point. Well, what you're going to do is you're going to set the cost to produce equal to the revenue. Solve this for x. So let me give you a head start. Subtract 400 from both sides, and then divide by your 200. So I'm getting X is 2,500. See if that's what you're getting. So what does this mean? This means the company must produce 2,500 wheelchairs to break even.
Sell them.
Yeah, sell. Actually sell them, yeah. Produce/sell, 2,500. The revenue, then if you put X is 2,500 into either of these, the revenue would be $1.5 million. So it really does take a lot. Like if you're interested in eventually running your own company, usually they say it takes 3 to 5 years to even get to a spot where you're making money because you have to put a big investment in.
Do you know the term that's used to describe, like there's the break-even point, what the percentages that company charge over that? I don't know, because there's a website you go on, like
It's
it'll
like
show you.
margin. It's called margin.
Yeah.
Yeah, my older brother, the one that has brain cancer, he's actually going to go in remission.
Wow.
That's awesome. It's really good news, yeah. He just finished his 6th round of chemo. He was at 90 to 95%. The cancer was gone. The oncologist said it's all going to go, but so that's super news. But anyway, he owns his own little company, and he sells like ink cartridges and stuff to schools. Those are his main thing. And so they have a margin. I think they try to mark it up 25%, you know, and then I think he's had his company about 5 years, and that's a small, very small business. They do like $300,000 a year in sales. So that's not a big business, but it's still nothing to sneeze at. But so I think after 2 years, they started making a profit. Because you have to then buy all this ink, and nobody's paid for it yet. But you have to have it ready to go. You know, it's like you put this thousands, tens, and hundreds of thousands of dollars in investment. But yeah, it's called margin. All right, the last thing here is profit. You want to get a profit, and a profit is found by taking your revenue minus cost. So it says find the profit function from the wheelchair example. So the profit function is revenue minus cost. You have to be careful. Our revenue was 600x, and it says you want to subtract the cost to produce them. Well, if cost is a sum or a difference, you're going to have to insert a grouping symbol here. And so this is 600x minus 500,000 minus 400x, and we can collect like terms. So my profit is 200x minus 500.